So this is live session number 9, and this is in continuation with the last time we discussed about gas turbine engines. So last time we discussed about the various parts of a gas turbine engine. That includes a compressor, a combustion chamber where the fuel is supplied into the compressed air. It burns and the hot gases form the combustion products. These combustion products move to the turbine. From in turbine they expand, release energy that is used to run the in case of power plants, this energy is used to run the generator. In case of automobile or aeroplanes, it is used to uh, generate thrust to generate propulsion to the aeroplane. Okay, so basically the gas turbine engines in automobile or aeroplanes works on an open cycle. So this open cycle includes reversible adiabatic compression, then there is a constant pressure heat addition, then again reversible adiabatic expansion, and then the combustion products are thrown away into the air in the atmosphere. Okay, so that's why it is an open cycle. The air comes from one end, it gets compressed reversibly adiabatically, the fuel is added to it, the constant pressure heat addition is there, then adiabatic expansion happens, and then these combustion products are thrown away into the atmosphere. So this doesn't complete the cycle, that's why it is called as open cycle. Okay, so this open cycle has application in aircraft, automobile, or sometime industrial gas turbines as well. Now, so now this open cycle works on Brayton cycle. So for the analysis purpose, we consider it as a closed cycle. So we join the points 4 to point 1, the outlet to inlet, assuming that the all the combustion products at the end of point 4 goes back to the anti to the compressor at point 1. Okay, for the sake of simplicity and analysis. So this Brayton cycle can be seen on the TS diagram as well. Okay, so it includes two reversible adiabatic processes and two reversible constant pressure processes. And the efficiency of this Brayton cycle is given as 1 minus 1 by Rp raised to power gamma minus 1 by gamma. Okay, that solely depends on the pressure ratio, the pressure from 1 to 2, point 1 to 2. So it is Rp is equal to P2 by P1, the pressure at point 2 by pressure at point 1. That is also equal to the P3 by P4, because this point 2 to 3 is a constant pressure line and point 1 to 4 is a constant pressure line. Okay, so this was the basic thing we discussed in the last lecture as well. Now let's move to the questions for this weekend, for this week. So the straight away question is isentropic efficiency, that is defined in terms of blank space, and RAM efficiency expressed in terms of something, are two methods by which the efficiency of intake system are analyzed in a turbojet engine. Okay, so in the case of a turbojet engine, two type of efficiencies are defined. The first one is the isentropic efficiency at inlet, and the second one is RAM efficiency at the inlet. So what are these efficiencies? So here you can see the isentropic efficiency at inlet is TO dash minus TA divided by TO1 minus TA. Here it is clearly mentioned that TO1 dash is a temperature which would have been reached after an isentropic RAM compression to P01. Okay, so basically the isentropic efficiency is defined in terms of raise in temperature. Okay, so this T naught 1 dash minus Ta is the raise in temperature. Okay, and here is the RAM efficiency is also defined, that is P naught 1 minus Pa divided by POA minus Pa. So again here P naught 1 minus Pa is the RAM pressure rise. Okay, so it is the increase in pressure. Okay, so here the RAM efficiency is defined as in terms of pressure rise, and the isentropic efficiency you can see from this equation is defined in terms of temperature rise. Okay, so uh, to look at the question again, it is isentropic efficiency is defined in terms of pressure rise, and the RAM efficiency is expressed in the terms of pressure rise. Okay, so first one is isentropic efficiency, that is defined in terms of temperature rise, and RAM efficiency is defined on in terms of pressure rise. Okay, so let's look at the options we have. So isentropic efficiency in terms of pressure rise, no. So the first option is wrong. Second is the isentropic efficiency is defined in terms of temperature rise, right? And RAM efficiency in terms of temperature rise, no. The third option is isentropic efficiency in temperature rise, right? And RAM efficiency in terms of pressure rise, right? Okay, so the option third is correct here, as it shows that the isentropic efficiency is defined in terms of pressure, temperature rise, and the RAM efficiency is defined in terms of pressure rise. So the answer to the first question is option C, option third. The isentropic efficiency uh, is defined in terms of temperature rise, but the RAM efficiency is defined on in terms of pressure rise. Okay, yeah. Okay, so that was a pretty straightforward question. The second, move to the next question. That is second question. Afterburners are used to blank space the thrust. Okay. So as you have already studied about afterburners, so what is an afterburner? So you can see in this figure that a turbojet engine. Okay. So if you see till here where I have marked, till here is a normal turbojet engine, right? So compressor is there, combustion chamber is there, expansion is there, and nozzle is there. But sometimes afterburners are added here. So what an afterburner does is, in the case of afterburner, some fuel is injected into the exhaust, and because of burning of this fuel, extra velocity, extra heat is generated, and that results in more thrust generation, more the more push it gets if we are using the afterburners, because it injects the additional fuel into the exhaust, and that results in the more heat generation and more thrust generation. Okay, so that is the principle of a afterburner. That's how a afterburner works. So basically, to look at the options, afterburners are used to increase the thrust, right? So afterburners are used to increase the thrust. The option first is correct option. Second one is wrong. No. Afterburners are not related to thrust. No, it is wrong. Afterburners are related to thrust because in afterburners the extra fuel is injected into the exhaust, that results in more heat generation, more fuel combustion, and more thrust through the nozzle. Okay. So this option is also right. None of the mentioned. This is all. Okay. So the option 1 is correct option here, because afterburners are used to increase the thrust, and you know the underlying science behind it, that in case of afterburners, an extra amount of fuel is injected into the combustion products, that results in more heat generation, more burning of fuel, and more thrust generation through the nozzle. Okay, so that's why afterburners are used for increasing the thrust. So option 1 is correct here. So now let's move to the next question. Here the next question is, in gas turbine engine, the pressure loss in the combustion chamber is mainly due to non-adiabatic flow, turbulence, and friction. Okay. Yeah. So here it is given that in the case of gas turbines, the pressure loss is always there in the combustion chamber. So what are the reasons behind that loss of pressure in the combustion chamber? So as you already seen in the videos, the course videos, the pressure loss is the main reasons of pressure loss occur in combustion chamber are, the first main is the friction, the second one is combustion chamber itself, and third one is turbulence and mixing. Okay, so the pressure loss occurs due to the friction through the combustion chamber walls. The air passes through the combustion chamber, and from the walls it get some friction. So that is the first reason. In the combustion chamber, the heat is generated. Because of the heat generation, the pressure is increased, and due to this pressure increase, the more losses are there. Okay, also the turbulence causes the pressure loss in combustion chamber. The turbulence and mixing both are necessary for mixing of fuel with the air, to get the good burning of the fuel, but also presence of this turbulence and mixing also results in the pressure loss in the combustion chamber. Okay, so look at the question again. It is being asked that in the case of gas turbines, the pressure losses in the combustion chamber is mainly due to the non-adiabatic flow. Yes. The turbulence, yes, turbulence has a major contribution to the pressure loss, and friction is the biggest component for the pressure loss in combustion chamber. So all those three, you know, three parameters are true for the pressure loss uh, in the case of combustion chamber. Okay, in the case of gas turbine and combustion chambers. Okay, so this is true. This is true in the case of gas turbine engine. The pressure loss happens in combustion chamber, and the reasons for this pressure loss are non-adiabatic flow, turbulence, friction, mixing. All these are the main causes of the pressure drop in combustion chamber. Okay, so for question third, the answer is true. The pressure loss occurs due to these mentioned reasons. Okay, yeah. So now let's move to the next problem. Yeah. So here comes the question. A simple turbojet engine is basically what? A propeller system, gas turbine engine equipped with propulsive nozzle and diffuser, chemical rocket engine, ramjet engine, or what? Okay. So basically, a simple turbojet engine is what? So here you can see a figure of simple turbojet engine. So what components you can see in this simple turbojet engine? So in this simple turbojet engine, you can see the inlet, the compressor, the shaft and combustion chamber, and the turbine. Further down, you can see the or nozzle or diffuser in case of supersonic engines. Okay. So in a simple turbojet engine, the main components are compressor, combustion chamber, turbine, and nozzle. Okay. So basically, this compressor, combustion chamber, and turbine combined make a gas turbine engine, and the extra nozzle is air for the propulsion purpose. Okay. So it is a nozzle uh, in case of subsonic velocities, and it is a diffuser in case of supersonic velocities. So here this whole part including compressor, shaft, combustion chamber, and turbine is a gas turbine engine, and this gas turbine engine is equipped with the nozzle. Okay. So now let's go to the question back. Here you can see a simple turbojet engine is what? Basically it is a gas turbine engine. Okay. And it is equipped with the propulsive nozzle. Okay. So this propulsive nozzle causes the main thrust we need to get propulsion, right? So this option is the correct option for the simple turbojet engine, and the option is a turbojet engine is basically a gas turbine engine that is equipped with the nozzle. The nozzle works as a propulsive device. So the right answer is option B for the question number 4. Yeah. Now let's move to the next question. So moving to the next question, the next question is an aircraft powered by Ramjet engine requires auxiliary power supply to attain velocity necessary for starting of engine through ram compression. Okay. So to again read the question, an aircraft powered by Ramjet engine requires auxiliary power supply to attain velocity necessary for starting of engine through ram compression. Okay. So yeah. So here the question is being asked about the Ramjet engine, and what is the Ramjet engine and how it works. So here is a figure given at the bottom right corner. So a ramjet engine doesn't include any fans. Okay, this doesn't include any fans. The air comes through the inlet, and the compression action happens due to the ramming effect of the incoming jet, the incoming air jet. Okay, or incoming air. So in the case of ramjet engines, there is no fan at the inlet. The compression basically occurs due to the ramming effect of the high velocity air. So here in the figure you can see from the right side, air comes uh, at the inlet of the ramjet engine. due to the ramming effect of this air and engine interaction, this air goes uh, ahead, and you can see the decreasing area, so it works as a compressor for it, and this compressed air is then goes to the combustion chamber where the fuel is injected and uh, the fuel is burned, and these burned gases then leave the nozzle through the exhaust, and we get our propulsion. Okay, so now the question here is, an aircraft that is powered by Ramjet engine requires auxiliary power supply to attain velocity necessary for starting of engine through ram compression. Okay, now a point to consider here is that a ramjet for a ramjet engine to work properly, there should be a particular minimum speed of air that should be fed into the ramjet engine. Okay, then only it will have that ramming effect of air, the incoming air, that would result in uh, that would result in the working of ramjet engines. Now, so to attain that particular velocity, the high velocity, okay, so if a engine is aircraft engine is powered by ramjet engine, and if you are starting off from zero, then there will be no air velocity to the ramjet engines. So no air velocity to the engine means no air will pass through it, no compression will occur, and no power will be generated. Okay, so to start these kind of engines, the engines that have ramjet engine in it, it is always necessary to have some alternate arrangement that will uh, you know that will make a aircraft reach high speed enough that the ramming effect of air can be felt into the compression. Okay, so basically, to reiterate it, in case of ramjet engines, we need an auxiliary power so that this auxiliary power can you know start off the aircraft and attain a particular velocity above which the ramming effect can be feel into the ramjet engine, and ramjet engine can work properly after that. Okay, so to start a aircraft that is powered by ramjet engine, we need auxiliary power supply to attain a particular velocity to get the uh, effect come into the picture, that ramming effect of the incoming air. Okay, so this option is correct, it is true option. A aircraft aircraft that is powered by ramjet engine need auxiliary power supply. Okay, for the starting velocity up to the velocity where the this where the ramming effect of air can be felt. So this is the right option. Now the next question here is, the blank space compressors are used in turbojets. Okay, so as you've seen in multiple pictures, the turbojet engines, okay, or other engines, uh, there is a flow in the direction of axis of the compression. So basically, those compressors that are used in the turbojets are axial flow compressors, and here the correct option is axial, because in the case of turbojet engines, and axial compressor are used. Okay, those multi-stage compressors are mounted on a same shaft, and thus they result in uh, the the combination of, not the combination, but these are the multi-stage compressors connected on a single shaft, and that is the axial compressors. So basically, the axial compressors are used in the turbojet. So the option 1 is correct. The radial, and those options are the wrong options. Okay. Yeah. So any questions till here? Kashish, any questions? Okay.
No, sir.
Okay. So let's move to the next part. Yeah. So the next question is, so in this question there are two statements, and we have to find out if one, two, or both the statements are correct. Okay. So the first statement is the fluid velocities are generally higher in turbo machines. So yes, this is the correct statement. The fluid velocities are very higher in the case of turbo machines, uh, that we already know. And the second statement is the changes in kinetic energy between inlet and outlet of compressor and turbine cannot be ignored. Okay. So if we see the kinetic energy, k is given by v square by 2, right? And at very high speeds, the value of v square by 2 would be significant. Okay. So the first statement was the fluid velocities are very high in the case of turbo machines, and the second statement is the changes in kinetic energy between inlet and outlet of compression turbine cannot be ignored. Okay. So yes, it cannot be
Yes,
ignored
sir. True,
because
sir.
what?
Yes, sir. Both are true.
Yes. So this second statement is true because at very high velocities, this component, the Ki component, that is v square by 2, is significant enough to consider and cannot be neglected. Okay. So this is the right statement. So both the statements are correct. And also because of the high velocities, in the case of turbo machines, you must have learned about the stagnant properties in the case of uh, these aircraft engines and all those things. So these stagnant properties are like H naught is defined as H plus C square by 2. Okay. So this stagnant enthalpy is you know is considered as the enthalpy of a system or a flow if this flow brought to the halt or brought to the stationary. Okay. So if we bring a flow to the stationary position, then what effect is being seen there is the velocity of that flow becomes zero, and this change in velocity is results in the change in kinetic energy. So this c square by 2 is the kinetic energy part that is added to the normal enthalpy of a system or flow. So that's how these stagnant properties are defined at high velocity uh, turbo machines. Okay. So this h naught can be further uh, can be written as cp t naught. H can be written as cpt plus c square by 2. So the stagnant temperature T naught can be written as T plus c square by 2c. Okay, so this is true statement. These are all both the statements are true. The fluid velocities are very high in the case of turbo machines, and due to this very high speed, the kinematic energy component cannot be ignored, and it has some significant uh, value in the case of high speed or in the case of turbo machines. Okay, so both the statements are correct. Now let's move to the next question, and what it is. The next question here is, which among the following engines operates on aircraft propulsion? Okay, so we are talking about the aircraft propulsion, and the question asks like which are the engines that work on the aircraft propulsion system. Okay, so as far as we know, we have talked about these things and we have studied these things earlier as well. So turbojet engine, yes, it works on aircraft propulsion cycle. The turbofan engine also works on that. The turboprop engine also works on that, and even Ramjet engine also works on aircraft propulsion cycle. Okay, so here the given four options are correct for the aircraft propulsion cycle. Okay, so all these four type of engines use the aircraft propulsion cycle. Okay, so this is a pretty straightforward question, and we all know that all those engines work on aircraft propulsion cycle. Okay, and moving to the next question here is,
Sir, what is Ramjet?
yeah, so Ramjet engine, let me tell you. Yeah, so can you see question number 5 here on the slides?
Yes, sir.
Yeah, so basically in this slide you can see this figure. Okay, I'm zooming it out. Yeah, so this is basically a Ramjet engine arrangement. So what happens in the case of Ramjet engines is, uh, you must have heard about a word ramming. Okay, so the ramming means to put something inside a vessel or some space by force. Okay, sometime for example, sometime you do you put some, wheat flour or maida in a box, and then you put some you know you push that flour or maida into the box by pushing it by hands or some stick or something. Okay, so that action is called as ramming, to force a fluid or something uh, to go inside a, uh, you know to pack itself inside. Okay, so that is called as ramming. Now here, in the case of ramjet engines, so all other engines use a fan to suck the air, push it into the compressor, and uh, then burning and all those things. But in the case of ramjet engines, the ramming effect, if the high velocity air is coming, and if it collides with a wall, it would exert a force on the wall, right? It will try to push the wall. Similarly, the velocity of the air always try to push the air inside the inlet of this engine. Now here, how the name ramjet is defined. So in the case of ramjet engines, the air comes directly without any use of any fan, and because of the velocity of the air, it goes inside the compressor. The compression of air happens because of the ramming effect of the air, not because of the fan pushing the air inside the compressor. Okay, so that is a ramjet engine. So in the case of ramjet engines, the compression of inlet air happens because of the ramming effect of air, not by the fan pushing the air inside the compressor. Okay, now the second thing here in the case of ramjet engines is to to get that ramming effect, to get that ramming effect uh, for the working of ramjet engine, air should be at sufficient high velocity. Okay, now the trick here is, if the air is not uh, fast enough, or the velocity of air is not enough, in those cases the air doesn't get compressed into the engine, inside the engine, and the engine doesn't work. Okay, so as we discussed already, here is, in the case of ramjet, any aircraft that is using ramjet engines, they need some other auxiliary arrangement as well, that will push the aircraft until it gets a velocity where the ramming effect uh, can be used. Okay, so that's why in the case of aircrafts, those work on ramjet engines, the auxiliary engine or power supply arrangement is made so that the air can be fastened enough to get the ramming effect into the ramjet engine. Okay, so that's what a ramjet engine is, and that's how it works. Okay, it uses the ramming effect of the air, not the pushing the air by using the fan. Okay, I hope it is clear to you.
Yes. Yes, sir.
uh, I cannot hear you. Can you please speak clearly?
Yes, sir. Clear.
Okay, okay, okay. Yeah. So now move to the uh, our ninth question here. Yeah. So in jet engines, for the efficient production of large power, fuel is burnt in an atmosphere of. Okay. So for efficient production of large power, what it means by efficient production of large power? So efficient production means, if the amount of fuel we are supplying is some x amount, if this whole x amount gets burned inside the chamber, then it is called an efficient production, right? The whole fuel is burning, right? Now the thing is, the air continuously flows, and it gets very less time for fuel to mix and burn completely. Okay, so it cannot react with all the oxygen available in the air uh, at that instant and burn the whole fuel. Okay, now the question here is, efficient production of large power, fuel is burned in an atmosphere of. Okay, so uh, so for efficient burning of the fuel, we need extra air, extra oxygen available uh, to get the fuel burn. So let's see the options here. So fuel is burnt in an atmosphere of vacuum. So as you know, for fuel burning, we need we need oxygen, right? So in the case of vacuum, there is no oxygen present, so vacuum is a wrong option. Fuel cannot burn in vacuum, neither in jet engines, neither in petrol, diesel, or any engine. Without the presence of oxygen, the fuel cannot be burned. Okay, so the first option is wrong. The second is atmospheric air. So in the case of atmospheric air, the fuel can be burned, but in the case of jet engines, at atmospheric air, the fuel will not burn completely. There will be some unburned fuels remaining. Okay, so that is not desirable, and that is also not an efficient production of power. So that option is also wrong. The third one is compressed air. So yes, compressed air is the right option, because in the presence of compressed air, we can inject more fuel, and as the compressed air contains more oxygen content, it ensures the complete burning of the fuel and efficient production of large power. So the option third is correct. And the fourth option is oxygen alone. Okay, so oxygen alone can help for the complete burning of the fuel, but oxygen alone cannot be supplied to the jet engines, right? So this is also a wrong option, because for efficient production of large power, a compressed air is the best option to burn the fuel in the combustion chamber. Okay, so
But sir,
yeah.
only oxygen alone, where in presence of oxygen alone, burn is completely made
Okay,
completely possible, sir.
yeah. So in the presence of oxygen alone, fuel can be burned completely, but we are talking about jet engines. So in the case of jet engines, uh, you know, consider an example like aircraft. So aircraft is moving into the air, and what are the means you can use to provide a pure oxygen to the jet engine? Okay, so that cannot be provided anyway. Okay, so pure oxygen you cannot provide. At vacuum it cannot burn. The atmospheric pressure will result in partial burning of the fuel. So the only option we have and freely available in the case of jet engines is the compressed air, that will contain more oxygen particles or more oxygen atoms, that can react with the fuel and burn it completely. Okay, so with the oxygen alone, the complete burning of fuel is possible, but supply of oxygen alone is not a possible thing in the case of jet engine. So that option is also wrong, and the right option is the compressed air is the right option uh, to get the efficient production of large power. Okay, okay, Payal, you got it.
Yes, sir.
Yeah. So here is the last.
Sir, in turbojet engine, inlet velocity is higher or exit velocity is higher? Which one is higher?
So you have studied about it. You tell me, like, which velocity should be higher.
Yes, sir. Inlet or outlet?
Yeah, you tell me which should be higher, inlet or outlet.
Inlet, sir.
Sir,
Why?
sir, high fuel.
Okay, so that is very basic or simple question. I would love you guys to think about it and get your answer yourself. That is very basic and simple question. Okay, you think about that question for some time, and if you still don't get the answer, I'm here. Okay, so till then, let's move to the next question.
Sir, please repeat again the previous question.
This ninth.
Question, Dada. Please again.
I didn't get you. Say again. Hello, Payal. Say again.
Sir, please repeat again previous question.
The ninth one.
No, sir. Kosis Dada, which questions asked?
Payal, can you type on the chat box? From there, I can read your question. You type your question in the chat box. Till then, let's see the final question of the evening. So the thermodynamic processes occurring in turbo machines are mostly adiabatic and their ideal processes are isentropic. Okay, so yes, this option is correct. The thermodynamic processes happening in the turbo machines are so indeed they are adiabatic, but they are not isentropic. Okay, and their ideal processes are isentropic. So yeah, this thing happens in the case of Kashish Dada. Okay. So
I,
Kashish was asking. Yeah, if Kashish is here, you can repeat your question. Yeah.
sir, I am asking which velocity is higher in turbojet engine, inlet or exit? Which should be higher in.
So Payal, did you get what Kashish asked? He is asking if inlet velocity is higher or outlet velocity is higher in turbojet engines. Right, Kashish?
Yes, sir.
Yeah. Yeah. So you guys think about it, like which velocity should be higher. It is a very basic and easy question.
Outlet velocity is higher because
Yeah, you are saying something. Yeah, Payal, you are saying something.
sir, outlet velocity are higher than inlet
Why? Yeah.
because this help to move.
Hmm. Okay. So it is simply the fuel is burning, fuel is going, fuel is going out with a very high velocity so that you get some propulsion, right? So only because of the high velocity jet coming or coming out from the engine, it results in a high thrust to the engine. Okay, so the main purpose of our this turbojet engine is to get the thrust, the propulsion, and that is only possible because of the high velocity thrust coming out of the engine. Okay, so outlet velocity is always higher in the case of propulsion engines, right? So yeah,
Okay, sir. Thank you.
yeah. So that was the thing. Okay. So any further questions you can ask? Payal, Kashish, any questions? If
Yes, sir.
no,
Please give me some time.
okay.
Sir, what is a turbofan engine?
Okay, so let me show you something. So, turbofan. You are asking about turbofan. So there are different type of engine: turbofan, turboprop, ramjet, Okay, so the basic difference between these engines is, in the case of turbofan engine, uh, there is a fan uh, at the at the front of the engine that uh, 1 minute, let me put a figure for you that will make it easy for you to understand. Basically, uh, okay, to explain it in easy terms, so in the case of turbofan engines, a fan is there at the inlet and a duct is there around the uh, compression combustion chamber and turbine envelope. So uh, in the case of turbofan engine, the partial uh, air goes through the compressor combustion chamber and then turbine, and the partial uh, air goes through the duct around it. So it results in the high amount of airflow, and at the exit of the at the exit of the turbine, this air that is coming from the duct outside the engine also mixes with it and exit at high velocities from the turbine, from the engine. So that is a turbo fan engine. So basically I would suggest you to google four type of engines: turbofan, turboprop, uh, ramjet, and
Ramjet.
Turbojet and Ramjet.
so turbojet, turbofan, turboprop, and ramjet. So once you google the four type of engines, you will get to know the main differences between these four engines. Okay, so
Okay, sir.
and also these turbojet, turbofan, turboprop. So these words jet, fan, and prop will help you to recognize which engine is which. Okay, and you will get to know what are the differences between these engines, what are the advantages and disadvantages as well. Okay, so basic differences, advantage, disadvantage, their application, all you will learn. You need to uh, look for the all four engines together, so that way you will be able to easily identify which engine is which and how it looks like and how it works. Okay, that way you will get to know the whole scenario in case of these turbojet, fan, prop, and ramjet engines. So do it once. If you had any still you had any doubt, then you can always ask me. I will clear all those things to you. I didn't put all those four engines into my slides, otherwise it would have been easier for you as well. So yeah, you guys look for it once. If you still get any doubt, you can ask me anytime. Okay, apart from that, do you have any doubts?
No, sir.
Okay, so we can close this session here. Vivek Kumar, you are asking something? No. Okay. So,
Sir, happy Durga Puja advancedly.
yeah, happy Durga Puja to everyone. Enjoy, celebrate, and be safe. Okay. So, let's close this session here only.
Okay, sir, thank you.
Yeah.